Hello and hi, Assalamualaikum. My name is Muhammad Amirul Farhan bin SYUKUR and I'm from class D M3A. My metric number is 14DM19F1005. Alright, first I want to introduce my group members.
Assalamualaikum. My name is Muhammad FARHAT from ADLEE. My metric number is 14DEM19F1011.
I'm Jemimah Kayelvili and my metric number is 14DEM19F1001.
Hi, Assalamualaikum. My name is AIMI and my last 4 digits matrix card number is 1009.
Okay, now I will start from objective. First objective is understand the basic of force, mass and acceleration, Newton's second law. Alright, the second is know and use the equipment for experiment. Next, analyze the result for the measurement. And the last one is to verify Newton's second law. Alright.
So now I want to tell about introduction of theory, which is the title is Force, Mass and Acceleration, Lab 2. So Newton's second law of motion pertains to the behavior of object for which all existing force are not balanced. The second law states that the acceleration of an object is dependent upon two variables: the net force acting upon the object and the mass of the object. The acceleration of an object depends directly upon the net force acting upon the object and inversely upon the mass of the object. As the force acting upon an object is increased, the acceleration of the object is decreased. So according to Newton's second law, acceleration is produced when a force acts on a mass. The greater the mass of the object being accelerated, the greater the amount of the force need to accelerate the object. So speed is the rate of change in distance. In other words, it is how fast the distance change in 1 unit of the time. In mathematics, displacement can calculate from the following formula. So the formula is a distance. How you want to get a velocity? So a distance must divide by time, so you get a velocity. So velocity is the rate of change in displacement. It is how fast the displacement change in 1 unit of time. Acceleration is a change of velocity. Next is what the formula to get a acceleration. So the formula is velocity must divided by time, so you get a acceleration.
Now I will talk about the equipment. The first equipment is scale. The function is to measure the weight of an item. So this is the figure of the scale. The number two is set of weight balance. The function is be used to gather the build up from a maximum weight to a maximum test load. So this is the figure of the set of weight balance. Number 3 is stopwatch. The function is it is a handheld timepiece designed to measure the amount of time that elapses between its activation and deactivation. So this is the figure of the stopwatch. Last is meter ruler. The function is it is a tool or device used to measure length. So this is the figure of the meter ruler. Then safety precaution. First is please do not do experiment without lecturer supervision. Number 2 is after finish experiment, please arrange equipment. Then I will talk about the procedure. Step 1 is set up the apparatus and material as shown in the figure 1 below. Step 2 is record a value of M1 and distance of H, constant value. Step 3 is release a system from O to N and record time when M1 drop down. Repeat this procedure for different tests. Step 4 is repeat this procedure with a different value of M1. Now step 5 is record the result at the table below. So this is how the figure look like in the experiment.
So I'm gonna proceed to the result, 6.0, the result. So based on the experiment, this is what it looks like when the apparatus and the material has been set up. In this experiment, we're gonna do two tests, test 1 and test 2. Test 1 is 20 centimeters of height and test 2 is 30 centimeters of height. So this is the test 1 result table, data information that I received from the experiment. The height is 20 centimeters, but we want to convert it to meter because we're gonna do the calculation. And this is the mass of M1 differently each: 100 gram, 50 gram, 20 gram, 10 gram and 5 gram. This is what we got after we convert it to kilograms. So the time is the time record of M1 from the top to the bottom, from O to N. So each of the mass of M1, we're gonna take 3 times of the time record. We're gonna add all these 3 and divide it by 3, so we can get the average time of M1 for each mass of M1. So for 100 gram, we got 1.13. 50 gram, we got 1.19. 20 gram, we got 1.29. And 10 gram, we got 1.20. And 5 gram, we got 1.47. And for velocity and acceleration, we got it based on the formula. Velocity equals to distance over time. The distance is the height, 0.2 meter, over the time. The average time is the one. So distance over time is the average time. So we're gonna fill up our result table based on the each mass of the M1. For velocity, the first one, 100 gram, is 0.18, and the second one, 50, is 0.17. 20 gram is 0.16. 10 gram is 0.17. 5 gram is 0.14. This is what we got, the velocity. And for the acceleration, also based on the formula, acceleration equals to velocity over time. So velocity we already got. This is the one that we got from the calculation that we did. So the velocity take for each over the time, the average time, the same. So velocity over time, for the first one, 100 gram, we got 0.16. 50 gram, we got 0.14. And 20 gram, we got 0.12. 10 gram, we got 0.14. And 5 gram, we got 0.10. So then we fill our table result of the acceleration. That's how we got the velocity and acceleration based on the test 1 experiment. So moving on to the test 2. Test 2 is 30 centimeters. So this is the result table for test 2. Also 30 centimeters, we're gonna convert it to meter because we're gonna do the calculation. This is the mass gram of the M1. Also the same, differently each: 100 gram, 50 gram, 20 gram, 10 gram and 5 gram. This is what we got after we convert it to kilograms. This is the time taken of M1. Time taken of M1 from the top to the bottom. And the same for each mass of M1, gonna take 3 time taken record, add it and divide it by 3, and we got the average time. So 100 gram, we got 1.05. 50 gram, we got 0.97. 20 gram, we got 0.83. 10 gram, we got 1.11. 5 gram, we got 1.20. 0.28. And also the velocity and acceleration we got from the based on the formula distance over time. So the distance is 0.3 over the time is the average time that we got. So for the 100 gram, the velocity that we got is 0.29. For 50 gram we got 0.31. 20 gram we got 0.36. 10 gram we got 0.27. 5 gram we got 0.23. Same goes for the acceleration based on the formula velocity over time. So the velocity we got already. This is the velocity that we got. Over the time, this is the average time. So velocity over time. So the first acceleration for 100 gram is 0.28. For 50 gram we got 0.32. 20 gram we got 0.43. 10 gram we got 0.24. 5 gram we got 0.18. And we fill up our result table from the calculation that we receive. So based on the test 1 and test 2 result table and information, we can do the discussion, the graph based on the result test 1 and test 2 table that we receive here. That's all. Thank you.
So now I want to discuss about discussion. So as you know, the graph that I have done, I have submitted at CDOS. So now I just want to discuss about the graph. So according to Newton's second law, the acceleration of an object depends directly upon the force acting upon the object and inversely upon the mass object. So now about graph at test 1. So therefore in test 1, it satisfied the Newton's second law as seen in graph where the 100 gram achieve the highest velocity and takes lesser time to reach the destination, where the 5G takes the longest with the lowest velocity. Next is in test 2, the lighter weight 20 gram achieve higher velocity over 100 gram velocity is the rate of change of position with respect to time when an external force acts on an object. The change in the object motion will be directly related to its mass. The relationship between the force, mass, and the acceleration is described in the equation. Force equal mass and acceleration. So this equation means that a new force acting on a body will change velocity, and conversely, a change in velocity will generate a force. Therefore, its effect the result of the experiment in test 2. So lastly, the error found in this experiment are the personal error. So come from careless, poor technique, or bias on the part of the experimenter. The experimenter may measure the time or the displacement incorrectly, or may be poor technique in taking a measurement, or may introduce a bias into measurement by expecting the result to agree with the expected outcome.
Okay, this is my turn to explain the conclusion. Alright, in my conclusion, we have understand the basic of force, mass and acceleration in this experiment. In the same time, we were new way to use the equipment and increase our knowledge. Next, the result for the measurement were analyzed together. Moreover, Newton's second law of motion was proved in this lab based on the data obtained. And lastly, the valve of this experiment were closed. The theoretical valve obtained with indicate little error was performed during the experiment. Alright.
Okay, now we moving on to the last one is the references. So there's a few references that we got. The first one is from the Wikipedia / Newton second law. The second one is from the physical classroom / Newton's law, second law, and the third one is from J. Apple / Newton, and the third one is from a textbook, Engineering and Mechanics. So that's all from my team, Group A. Thank you for watching this video, and that's all. Goodbye and Assalamualaikum.